Hey, what's up guys? Hope all of you are doing great, and I'm sure the preparation must be going on really well. I'm so excited today to come in front of you and give you the solutions for this brilliant topic. It's an amazing topic. The topic is mensuration. Mensuration, it's part of geometry wherein it's all about the shapes, the objects, and the area and the volumes of these objects. Okay, be it a sphere or be it a cube. So you'll have to visualize things, and it's the work that you are giving to both of your right brain and left brain, right? Where your right brain is all about creativity, visualization, and then of course to find the area or the volume, you will have to use your left brain, that is numbers. You'll have to activate your left brain and find these values with the formulas and all that. So it's the combination of these two. And again, I'm using this particular website, geogebra.org. What an amazing creation, what an amazing website that they have done. You will see why am I praising this particular website so much. I have used this extensively for heights and distances, and then the geometry, of course, right now for mensuration part. Okay, so let's get started. Great. So yep, welcome to the video solution section. And mensuration, yes, let's see how this is. If in case there are few students who are something like you don't have a clue about mensuration, I'm sure this particular video is going to give you a lot of information, a lot of idea, and it's going to open up so many different angles to think about mensuration. Great. So first one is this very simple straightforward question. If the length of a diagonal AC of a square ABCD is 5.2 centimeter, then the area of the square is, all right. So I have already done some work for you guys and I've come prepared today. All right. So there you have, of course, I've come prepared today. Don't laugh. Where is my pen? There you go. All right, fine. So if the length of the diagonal AC of a square ABCD is 5.2 centimeter, then the area of the square. Great. So they have mentioned this AC, which is the diagonal of the square, all right, as 5.2 centimeter. Okay, then the area of the square. Now see, if in case this is A and this is of course A because it's a square, then what will be AC? AC is going to be square root of 2a square, or it is root 2a. So remember this is your first formula of the day. Diagonal of a square is root 2 times its side. Remember this, very important, very basic. Okay, now what is that we are looking for? We are looking for a square, that is the area. All right, so how do I get a square out of this? Let me square this diagonal. So if I square the diagonal, I get 2 times a square, and which is equal to 5.2 square. All right, 5.2 square. So this is nothing but 52 square. There are so many amazing formulas to actually find this square. There is a method. Okay, I will be using that. I'll just give you a small brief of it. If you find any number between 50 and 80, you can find the squares of these numbers very quickly. So how is that? If in case, let's take this particular example, 52. Okay, 52 is more than 50 by how much? 2. So the last 2 digits of the square of 52 square is going to be 04. Okay, and then 25 is the magic number. All right, 25 is the magic number in this particular system. You add this surplus, that is 2, the square of which you have written here. You add this surplus to 225. Okay, that becomes 27. So 52 square is 2704. For example, 54 square. Okay, what is 54 square? 4 square is 16. How did I get 4? 54 is more than 50 by how much? 4, right? So you square that number and write in the last two digits. Okay, then you add this surplus 4 to the magic number 25. Okay, that will be 25 plus 4, 29. I'll make a video for these, and there is no necessity for that. You can search this particular technique in the YouTube, and I'm sure there will be videos on this. Okay, Great. So now I know that the square of 52 is 2704. So 5.2 square is going to be 27.04. Divided by 2 is a square. So which will be equal to how much? To 27.04. So 26 by 2 is 13. 1.04 by 2 is 0.52. 0.52. So it is going to be 13.52. I don't have to even go for those decimal parts, because the moment you see 13 point something, look at the options. The only option which has this 13 point something is option 2 or option B. There you go. The first question, very basic question. And how many seconds question? 20 seconds, 15 to 20 seconds, not more than that. All right. How? Very simple. Diagonal AC is nothing but root 2a, and which is equal to 5.2. The square of this is 2a square. So a square is equal to 5.2 square. So 5.2 52 square is 0.4. 25 plus 2, that is 27, divided by 2, 13 point something. Right? The answer is option B. So that's all. Okay. I mean, I'm explaining you, so probably I've taken a little more time, but when you are doing it in the exam, you will have to be really fast. Great. Next one. Next question. The diagonal of a square is 4 root 2. Okay. The diagonal of a square is 4 root 2. For example, let's say, let me take this particular square. So this is 4 root 2. All right. That's what they're saying. Next, the diagonal of another square whose area is double that of the first square. So I've written another square here whose area is approximately double that of the first one. I mean, in the question it has to be accurate, but I'm talking about the diagram. Yes, so this is the diagonal that we are talking about, and that the length of which we're supposed to find out. Now, you have already learned that diagonal of a square is equal to root 2 times a, which is equal to, in this particular question, it is 4 root 2. Yes, then what is a? A is 4. A is 4. If a is 4, what is the area of this square? That is 16 square units. If this is 16 square units, what has to be this one? It has to be 32 square units. If this is 32, what is the area? I mean the side. Sorry, the side is root of 32. If this is root of 32, if a, let me call this as b. Okay. If this is root of 32, then the diagonal in this particular equation, I mean the square, has to be equal to how much? Root 2 into root 32, which is equal to root of 64.8. That's all. Great. Very nice question. Very simple question, in fact. But you know, the way in which we can solve this is so beautiful. It's so nice. So amazing. Next one. I just saw the previous two videos. All right. And I could clearly sense that there is a problem with respect to video and audio synchronization, and that is happening because there are too many softwares running in my laptop right now, especially this website geogebra.org. I'm using too many features in this website because of which this particular problem is happening, and I'm sure it's going to be a lot of distraction even for you to see me, and then I say something and you hear that after 1 or 2 seconds, then you have to concentrate also on what I write. So to avoid all this distraction, these distractions, I have decided one thing, that I will not be visible in this video. Okay, I will be going off the record in terms of video. You can listen to me, you can listen to the explanation. So if you have any doubts, please post those doubts in the comment section. I'm sure we will help you to resolve all those doubts. All right, great. See you soon. Happy learning. Maybe somewhere in between I might come. Okay, great. Okay, question number 3. I will be continuing with the explanation. Please pause the video, read the question. Okay, if you have taken up the mock test, you will be able to easily relate to these questions if you have attempted it. If not, no problem. Fine. So difference of areas of two squares. Basically, let's assume there are two squares. This is 1 and this is 2. Okay, drawn on two line segments of different lengths. Of course, this is one line segment, this is another line segment, two different lengths, and the difference of these squares is 32 square centimeters is what is given. Find the length of the greater line segment if one is longer than the other by 2 centimeters. If this is x, this is x plus 2. Simple. Okay, so x plus 2 square minus x square is equal to how much? 32. So you can see here a plus b whole square expansion. So in that, x square and x square gets cancelled. You will be left out with 4 plus 2x is equal to 32. Hope this is clear. 4 plus 4x. A square plus b square. B square is this 2 square, and then 2ab is 2 into 2 into x. 2 into 2 into x, that is 4x. So 4x is equal to how much? 32 minus 4, that is 28, or x is equal to 7. But in the question, what they have asked is find the length of the greater line segment. So greater line segment is x plus 2. So x plus 2 is 9. Your answer is 9. Option B. Great. Alright. Question number 4. The ratio of the area of a square to that of the square drawn on its diagonal is. So this is the first square. Let me name it as ABCD. Okay. This has some area, alright, and the ratio of that to the square drawn on its diagonal. The diagonal is AC. Okay. Now what we'll do is we'll assume AB as A. If this is A, AC will be root 2A. We have already seen this. So this is what we want. What is this root 2A? Root 2A is the side of this new square. Okay. So the ratio is going to be A square is to root 2A square, which is equal to how much? 1:2. You can also see here, if you count these small squares, you know, of the graph of the background, then this will be half of that of the number of squares what you can see in the bigger one. Okay, fine. That's the fun in mensuration part. You can always see and measure and see whatever you're doing is actually right or not. Great. Anyways, this is a very simple question from the exam perspective. This is like within 5 seconds question. Okay, the moment you understand the question, you will have to arrive at this equation. You need not even draw all this. Definitely not. This is only for making things easier for you. All right, next one. Answer is, let's mark the option B, 1:2. Next one. The breadth of a rectangular hall is 3/4 of its length. Let's say this is length, then the breadth is 3/4 of its length. Area of this floor is 768 square meter. So area is nothing but length into breadth in a triangle. So it is 3/4 into L square must be equal to what? 768. So L square is equal to 4 into 7, 68 by 3. 3 2 times, 3 5 times, and then 3 6 times. And L is equal to square root of this value. So square root of this is going to be how much? Square root of 4 is 2 and 256 is how much? 16. So L is 32. Now what is that we are looking for? The difference between these two. The difference between these two is how much? L minus 3/4L is actually 1/4L. So what is 1/4L? It is 32 divided by 4, which is equal to 8. Units, this is in square meters, so it is going to be in meters. That's it. Answer option A. All right. So very simple, straightforward question. Less than a 20-second question actually. Question number 6. ABC is a triangle with base AB. Okay, this is AB and this is C. D is a point on AB, okay, such that AB is 5 centimeters, DB is 3, not centimeters, they have not given the unit, 3 units. And if this is 3 units, AD is going to be 2 units. AD is 2 units and AB is 5 units. Fine, great. So what they have asked the ratio of the area of triangle ADC to the area of triangle ABC. Now, what is the area of a triangle? Area of a triangle is, we all know, half into base into height. Okay. Now, we are talking about these two triangles. One is ADC, other one is ABC. So, in these two triangles, we know the value of the base. The base of ADC is 2 and the base of ABC is 5. What about the height? The height of both the triangles ADC and ABC is going to be same. Observe it closely because it's the same base, and this vertex that we are talking about C is also same for both the triangles. So in that case, the height, for example, let's say if this is the height, all right, so it is going to be same for both triangles ADC and ABC. So then what happens if we are talking about the ratio of area of, let's say, ABC to that of the area of ADC, then it will be equal to the base of ABC divided by the base of ADC. Why? Height is same and 1 by 2 gets cancelled, right? So, or in other way, what you can say is, if height is constant, then the area of two triangles are proportional to their base. Okay, great. So this is equal to how much? Base of ABC. Base of ABC is 5 and base of ADC is 2. Okay, so this is equal to area of ABC by ADC. But in the question they have asked ADC in the first, that should be the first ratio. The second one has to be the area of triangle ABC. So it's going to be 2:5. As simple as that. So in the entire question, first thing that you need to solve, first thing that you need to know to solve this problem is your destination. Your destination is area, and the area of the triangle is given by this formula. And then check what data that you have with you. You have the base for both the triangles, and if you have the base, then think about what should be the height for both the triangles. That's when you arrive at this observation that height for both the triangles must be same. The reason being, it's the same base. The same base means the distance from the vertex, that is C, to the bases are same. That is nothing but the height. So once you establish this logic, the next thing is proportionality. So area ratio is equal to base ratio, then you get your answer. Fine. Nice question, very nice question. Let's go to the next one now. Before we even solve this question, I want you guys to observe this and understand one property of triangle, that is, when you join the midpoint of all the sides, for example, this is, let's say, ABC and this is DEF of an equilateral triangle. Okay, this is not the reflection of the question. Just to give you an introduction to this question, if it's an equilateral triangle, D is the midpoint of AB, E is the midpoint of AC, and if F is the midpoint of BC, okay, if this is the scenario, you can clearly observe the area of this is what? 1/4, not half, 1/4 of the area of the bigger triangle. Even this is also similar to the other one, and the remaining two will also be same. You can make this observation, and you can also prove it with the similarity property of the triangles. Now what has happened is, the triangle that they have given in the question is a right angle triangle. Okay, this is a right angle triangle. Fine. Even in this scenario, the area of this one is going to be 1/4 of the area of the bigger triangle. That is something that you need to understand and observe. So once you have established that relationship, then you can proceed with the solution for this question. So DEF, let's say, and they have mentioned that the area of the triangle are 3, 4 and 5. So how did I arrive at this conclusion that this is a right angle triangle? By these numbers 3, 4, 5. They are Pythagorean triplets. Pythagorean triplets, the triangle can have these three values as the sides only when there is a 90-degree, or if it's a right angled triangle. Now the length, if you can see here, this is going to be, let's say, 3 centimeters, and I'll call this as 5, and this is going to be, sorry, this will be 4, and this is going to be 6 units. Clear? Because why 6? This is the hypotenuse. Now area of this bigger triangle, the right angle triangle ABC, is half into base into height. Base I will take it as 3, then height will be 4. So I can get the area of the bigger triangle, which is equal to 6 square units. All right. Now the triangle formed by joining the midpoints of this triangle, what we are supposed to find? The area of the triangle. So that is going to be 6 by 4 square units or it is 3 by 2. Option C. Alright, question number 8. Before we proceed with question number 8, I want you guys to focus on this diagram. Alright, what I have done here is, this is A, B and C, the same previous question diagram, wherein all the sides, on side, for example, AB, I have marked D, which is the midpoint of AB. Similarly, E is the midpoint of AC, and then let's say F is the midpoint of BC, and I have joined these points. So then I get this triangle DEF. Okay. Now, if you observe, I will change the overall dimension of the triangle. If you observe, all these 4 triangles that you can see, 1, 2, 3 and 4, okay, the way they change is very similar. All right, I want you to observe this, and later we'll derive one conclusion out of this. And what is that? The area of all these 4 triangles, smaller triangles, is same. ADE area is equal to DEF area is equal to DBF and EFC. Okay, now there are multiple proofs for that. You don't have to actually go for it, but anyways, since it is interesting, I will just show you one of the proofs that someone has given. Alright, so what they have done here is, they have gone with the congruency and the similarity. Okay, if DE, that is the midpoints, if if they are parallel, if D and E, if they are the midpoints of AB and AC, then DE becomes parallel to BC. And if this is the midpoint and this is the midpoint, then the length of DE will be equal to half of that of BC. Alright, that's the first thing. The second thing is, since ADE is similar to ABC, because DE is parallel to BC, and then angle A is the same one for both, and then you have, since they are parallel, angle D will be equal to angle B. Similarly, E will be equal to angle C. Fine. So when the 2 triangles are similar, the ratio of their areas will be equal to the ratio of the square of any of the sides. For example, if in this case the ratio of ABC to ADE will be equal to B square is to DE. Okay, so like that you get the ratio of ADE to ABC as 1:4. Similarly, now if you look the same triangle from this particular direction, from this angle, okay, then DF is half of that of AC. So that gives you the similar kind of explanation. BDF and BAC, the ratio of those triangles is 1:4. Okay, so this will be equal to 1, this will be equal to 1, this will be equal to 1, and the overall entire area will be equivalent to 4. Then that leaves us with the middle one, the DEF, which must be equal to 1, because 1, 1, 1, 1 must add up to 4. So this gives a very nice explanation, which we can observe in this particular diagram, that if I change the direction, the overall the side length and all, then you can clearly see that these smaller triangles, they behave in a very similar way. Okay, so this is one thing that you need to remember. This particular overall simulation should create one print in your mind that this is how it works. All right, so once you have this understanding, once you understand this this property of the triangle very clearly, the next thing is very simple. What will be the area of this? Before we even proceed to that, read the question. DE are the midpoints of the sides AB, okay, AB and AC. Respectively of triangle ABC in the figure given below. It's same figure. The shaded region of the triangle. This shaded region is nothing but we're talking about this, right? We're talking about this. So what will be the area in terms of percentage of the whole triangle? This will be nothing but 3/4. Overall 3 triangles, 1, 2, 3, and then in the bigger triangle you have 4 triangles including this, right? 3 by 4, which is nothing but 75% of the bigger triangle, that is ABC. Hope this is clear. Okay, fine. So when you are studying something, when you get any kind of doubts, you have your teacher in front of you. I'm not talking about me, I'm talking about Google. Okay, so search in Google, there are so many websites with so much of information, and one or the other thing will lead to some very new learnings. Now just imagine, if you know this property, if you know this concept, this problem can be solved in 2 or 3 seconds right after you reading the question. Let's say you read the question in around 7 to 8 seconds, and then another 2 or 3 seconds is to just understand this and then solve. Within 10 seconds you would have actually solved this problem. Great, let's move on to the next one. All right, next one. Sides of a triangle are in the ratio 2:3:4. So this is 2x, this is 3x, and let's say this is 4x. Okay, then the perimeter is given as 18. So 2x plus 3x plus 4x is equal to 18, which is nothing but 9x is equal to 18, or x is equal to. So the length of this is actually 4 units, this is 6 units, and this is 8 units. Great. Now if we know the sides, we can easily find the area. We know that formula. The formula is S into S minus A into S minus B into S minus C. But what is S? S is semi-perimeter. Okay, if perimeter is 8, what is semi-perimeter? S will be equal to 9. So substitute the values now. So S is 9 into S minus A is going to be 9 minus 4, which is 5, and then 9 minus 6 is 3, and then 9 minus 8 is 1. So square root of or else I'll do one thing. So square root of 9 is anyways 3, root of 5 3s are 15. So answer is option D. Brilliant, easy question. Next one. Yes, the area of triangle formed by the straight line 3x plus 2y is equal to 6. Now how do you determine this is the straight line? Very simple. Substitute the value of x as 0, you get y is equal to 3. Okay, that means one of the points is x 0 comma 3, that is when the value of x is 0, y is 3. Okay, this is the first point. Similarly, substitute y is equal to 0. If you substitute y as 0, then you get x is equal to 2, right? So that is this point. When y is 0, x is 2. All right, so this straight line and the coordinate axis, that is x axis and y axis, we're talking about this area, okay, which is nothing but half into base into height, which is half into 2 into 3 square units, you get 3 square units. Great, brilliant. Okay, the area of square inscribed in a circle of radius 8 centimeters is, let me just zoom this. If you are using your smartphone, you must be able to watch this properly. Area of square inscribed in a circle of radius 8 centimeters. So this is 8 centimeter. Radius is 8 centimeter. So then what is the diameter? Diameter is 16. Correct? This is 16 entire thing. So what is 16? If I take a as the side of square, root 2a is 16, or a is equal to 16 by root. So if that is the case, what is the area? A square is equal to 16 square is 256 divided by 2, and you will get 128. Option C, 128 square centimeter. Easy question, very simple. All right, hope you have understood. I'll move on to the next question. All right. So if a wire is bent into the shape of a square, the area of the square is 81 square centimeter. When the wire is bent into a semicircular shape, the area of semicircle is. Now we have a wire, all right, it has been bent into a square. Now after that, it has been bent into a semicircular shape. Now semicircular refers to, I will have to join these 2 points as well. Okay, now this is the semicircular shape. Fine. Now the information what they have given is the area of this square is 81 square centimeters. Now before we even proceed, what's the logic? The logic is the length of the wire in all these 3 diagrams, that is this one and the square and the semi circle, the length of the wire remains the same. Okay, I mean, you are bending the wire, right? But the length remains the same. That's the logic. Now with that, can I say the perimeter of the square is equal to the length of the wire, and that is equal to the perimeter of the semicircle? Of course I can. Great. So if I know the area of the square is 81, then the value of the side will be equal to 9, that is square root of 81. Cool. So once you get the side as 9, then what will be the perimeter of the square, which is nothing but 4 into 9, or perimeter will be equal to 36 units, and that is the length of the wire. Now that will be same as that of the length of this one, that is the semicircle. So what is the formula for the the circumference or the perimeter of the circumference in a circle? It is 2 pi r, correct? 2 pi r. Then we are talking about, let's say, this particular part, okay, of the semicircle, which is half of this. So this will be pi r, and then I have diameter, which is 2r. So the sum of these two must be equal to 36. Okay, with that I will get the value of r, and once I get the value of r, I can easily get the area of the semicircle. Okay, that's the whole logic. Fine. So don't go with the scale now. I have just drawn the diagram without any scale. It's not 81 square centimeter, or this is not exactly the perimeter is not same as this one, and this length is not same as the length of the wire. This is just for explanation. Fine. So what I was saying is pi r plus 2r must be equal to 36. Correct? So or r into 22 by 7 plus 2, which is 7, and then 22 plus 14 is equal to 36. So you can cancel it. You get r is equal to 7 units or centimeter. If you know r is 7 centimeter, what is the area of semicircle? Pi r square by 2. So you have 22 by 7 into 7 into 7, that is r square, divided by 2. 11 sevens are 77 centimeters square. Hope this is clear. Great. Let's move on to the next one now. Before I proceed to the next question, I want you guys to be with me completely for the next 3 to 4 minutes. I will tell you a beautiful concept in geometry, an amazing one, with the help of which you can solve the problems if in case you get on these lines within seconds. What is that? With the same perimeter and different areas, all right? For example, let's say that you have a wire with you, and you bend that wire into a square. Before square, let's say a triangle. You bend that wire into a triangle, and then you bend that wire to a square, and then to, let's say, hexagon, and then to a circle. All right. So when you do this, which of these geometrical shape will have the maximum area? Which of these will have the maximum area when the perimeter is same? So I was just googling, and I found this very interesting way of proving it. You can go to this proof later. I don't want to go to the details here. Open curriculum.org, and definitely you will get it. But the conclusion, the way in which they have expressed the conclusion, just I'll read it out for you. The triangle with perimeter 1 unit. Here they have assumed the perimeter as 1 unit, and then they have deduced it. But you can go with any perimeter, but it has to be same for all the geometrical shapes. So the triangle with the same perimeter has the smallest area, followed by square, then hexagon, finally circle. So that's the observation, that's the result that they have got. With this result, what is that another conclusion that they have derived? That is beautiful. That is, it is reasonable to conjecture based on this evidence that as the number of sides of the regular polygon with perimeter or with equal perimeter increases, so does the area. When you increase the number of sides, the area also increases, given that the perimeter is same. So if you have a wire and you bend that into a triangle, and then you bend that wire into a circle, all right, the area of the circle will be predominantly bigger or higher than the area of the triangle. So, or I can go with square and triangle. So the area of the square is more than the area of the triangle when the perimeter is same, because the number of sides in square is more than that of the triangle. Hope this is clear. And then they say this would mean that regular octagon would have greater area than a regular hexagon but less than circle. Alright, so amazing article. So for example, in these four, triangle will have the minimum area, and then the square, and then hexagon, and then circle. Okay, though we cannot use this particular property for this question. Okay, reason being they have asked semicircle. All right, if in case they had asked circle instead of semicircle, definitely we could have used this particular property to rule out some of the options. All right, great. So hope this was useful. We'll move on to the next one now, question number 13th. Okay, look at this one. If the area of a triangle with base 12 centimeter, okay, let's say it's a triangle ABC and the base is BC, and they've given this is 12 centimeters, is equal, the area is equal to the area of a square, this is the square, with side 12 centimeter, the same one. Okay, the altitude of the triangle will be, so what will be the altitude of it, what is going to be the height of it? So that's the question. Now I don't want to solve this question, I want you guys to observe this very closely. Okay, now look at this. If I drop the if I bring it somewhere here, all right, and I will draw one line. One second, I'll draw one line. Yeah, all right, now observe this part of the area is common between triangle and the square. So what is the extra of square? Extra of square is this, and extra of triangle is these two. Now if this has to be same to this, and if this has to be same to this, then can I say that the height must be same to the height of, to the length of the square? Hope you are following. When that happens, okay, the area of the triangle will be equal to area of square. So if that is the case, my height, this particular part has to be how much? Should be equal to the length of the square, which is nothing but 12 centimeter. If this is 12, this is also 12, and you have 24 centimeters as the answer. Great. You can definitely solve the same thing with the equation, no doubts about it. But this is so nice, this is so beautiful to draw and make some conclusions out of the observation. Hope this is clear. I will not solve it with the equation. You definitely, I'm sure you can solve it, it's not a big deal, but I want you guys to observe this. Geometry can be so much of fun, and you can solve the problem so easily if you observe nicely. All right, let's move on to the next one. Next one, 14th one. A square and an equilateral triangle are drawn on the same base. Fine, I have drawn the diagram for you. The ratio of their area is, so ratio of square is to triangle, right? So definitely this is more than triangle, so this is ruled out, and then this is also ruled out. I will have to choose between either this or this. Now observe very clearly. So they are saying it's an equilateral triangle, so these three sides must be same, and this also must be same because it's also the length of the square, which is same as this. This particular point does not lie on the side of the square. The reason being, it's the same line, the length of this line and this line is same. So you can visualize it in something like, if this line is brought in this direction, if you bend it, this point comes and settles here, then there must be a gap between this line and the point. Okay, so now this gives me a very clear explanation that the ratio of the area of square to triangle cannot be 2:1. Why? If the scenario was something like this, then I could say that this part and this part, when you add, definitely it will be equal to triangle, and the ratio is 2:1, correct? But now, since that is not the case, since this point is not lying on the line, then I can clearly say that it is not 2:1, and I can go with option 4 is to root 3. I mean, just by observation. If we have to solve this law, I mean, with the equations, how do we do that? Very simple. I'll assume this as A. If this is A, what is the height? Height will be equal to, this will be A by 2, and this is A, and the height of the equilateral triangle is something that you are supposed to remember. You will get it as root 3 by 2A. Okay, and how did we get that? Hypotenuse rule, A square minus A square by 4, and the root of under the root will be equal to the height, okay, which will be nothing but root 3A divided by 2 if you calculate. So this is root 3 by 2 into A. This is the height. Now the area of the triangle will be nothing but half into base into height, half into A into root 3 by 2 A is to area of square, or yeah, fine. This is square and this is triangle. So you will get root 3 by 4 is to 1, or 4 is to root 3. When you change these two parameters, if you interchange it, you will get square is to triangle area as 4 is to root 3. As simple as that. You can also do it with the equations, but you know, why do you have to do it when you can just observe and rule out the options within seconds? That's my point. Fine. So I mean, see, for some of you, solving the problem through diagram could be easier by observation. For some of you, solving the problem through the equations could be easier. You go with your strengths. All right, I'm no one to judge or give you that or tell you that, you know, do only this particular method. You are the better judge for that. You find out which is better. Is it visualization or is it equations? Whichever is good for you, go for it. One side of a square is increased by 30%. To maintain the same area, other side will have to be decreased by, okay, let's say this is the square, the initial square ABCD. Fine. Now one side, that is this AB, this was increased, okay, let's say to EF. Fine. Now because you are increasing it, to keep the area same, this particular side, this has to decrease, and let's say this point is G. Okay, now the area of ABCD is A square, and the area of GEFC, the rectangle, is, let's say, B into C, where this is B and this length, entire length is C. Okay, now what is C? C is 1.3 times A. What is B? B is, or B has to be A divided by 1.3, so that these two must be equal. Great. So you are reducing it by how much? You can find out, that is A minus, or yeah, A minus A divided by 1.3, 1.3, 0.3, right? 1.3 minus A is 0.3, this times A. This will be equal to how much? Let's say 30 divided by 13, or 300 by 13, and then percentage inverse you have. So 13 how many times? 13 3s are, or 13 2s are 26, and then you have 40, 13 3s are 39. You get 23 point. The remainder is going to be 1. So 1 by 13, 23, 1 by 13. I think this must have been 23 1 by 13, not 23 1 by 3. Maybe it's a printing mistake. So the answer is option A, 23 1 by 13. Okay, let's move on to the next one. Okay, from a point P, which is at a distance of 13 centimeter from center O of a circle of radius 5 centimeter. This is 5 centimeter, this is center O, and this is point P, and this length is 13 centimeters. Okay, this is 5 centimeters. In the same plane, a pair of tangents PQ and PR are drawn. Area of triangle PQOR. This triangle, I mean this, not triangle, sorry, quadrilateral PQOR is something that we are supposed to find out. Now, I mean, this is something that I'm sure you would be knowing it. The tangent and the radius, they form 90 degree. Okay, so you get two right angle triangles. One is QOP and the other one is POR. All right. So, and you also have the value of the base, okay, but you don't know the length, you don't know QP, but you can find out. Pythagorean triplets 5, 12 and 13. Similarly, this is also 5, 12 and 13. Both has to be same, symmetry, correct? So now it's very simple. The area of the quadrilateral is nothing but 2 times the area of the triangle, which is 2 times the area of triangle. Area of triangle is half into base. Base, I'll take it as radius, that is 5, into height is 12. All right. 6 5s are 30, 32s are 60 square units or centimeters. Option B. Next one. Next one. In triangle PQR, line drawn from the vertex P intersects QR at a point S such that QR is equal to 4.5. So QR is equal to 4.5. This is not 4.5. So this will be 3 then. QR is 4.5. SR is 1.5. Then the ratio of the area of triangle PQS, this one, and then triangle PSR, this one, right? PQR and then S, this is 3, this is 1.5. Great. Now, how I would solve this problem to find the area of the triangle, I mean the ratio of the area is, just imagine, look at this. If you keep the height same and change the point vertex wherever it goes, all right, what is constant? The height is constant for both the triangles, that is PQS as well as PSR. Hope this is clear. So since the height is constant, since the height is same for both, when the base are these two, that is QS and SR, when these two becomes the base of the triangle, and I keep this vertex moving anywhere, but the constraint is it has to be on this line, so that the line that you are seeing on that line, yeah, all right, so that the height remains the same. If it is be it in any of the point, the height remains the same. Then the area, what is the formula of the area? Area is half into base into height. So height of both the triangles is same. You have this element. So the area ratio will be nothing but will be the ratio of the length of the bases. So the area of the ratio of the area of these two triangles will be equal to 3:1.5. So initially they have asked PQS. So corresponding side is 3. Similarly, this one is 1.5. You get 2:1. Option D. Hope this is clear. See, very nice question. You actually, if you know this concept, and there is no big concept here, just that the height is same, that's all, nothing else. And this thing and all, I'm just giving you, I'm just telling you, so that your concepts in this geometry part becomes more stronger, that's all. Fine. So it's actually within 10 seconds problem, 10 to 15 seconds problem. All right, let's move on to the next one. Okay, a parallelogram has sides 60 and 40 meter as the length. One of its diagonal is 80 meters. I'll take this as 80 meters. Its area is very simple. These two are similar triangles. So if I have to find the area of the whole parallelogram, what I can do is I can find the area of this triangle and then multiply it by 2. As simple as that. So area of triangle here in this case is, we can use the formula square root of s into s minus a into s minus b into s minus c. Hope this is clear. So where s is equal to a plus b plus c by 2. So which will be nothing but 60 plus 40, 100, 180 by 2, 90. So area will be equal to root of 90 minus 90 into 90 minus 80 is 10, into 90 minus 60 is 30, into 90 minus 40 is 50. I will rewrite this as root of 90,000 multiplied by root of 15, which will be 300 root 15. So this is the area of triangle. I want that of parallelogram. So it is nothing but 600. It is 2 times this 600 root 15. Hope this is clear. Option B. Next one. If A and B are the if A and B are the lengths of the sides of a right angled triangle whose hypotenuse is 10 and whose area is 20. Area is 20. What is area? Half into A into B in a right angled triangle, right? So if this is a right angled triangle, this is a very simple one, so I'm just going directly without using this particular website. So A, B, and let's say this is H, which is 10. So this is equal to 20. So I get AB to be equal to how much? 40. And then what is A square plus B square? A square plus B square is equal to 10 square, which is 100. So A square plus B square is equal to 100. Then what is A plus B whole square? It is A square plus B square plus 2AB. So let's substitute these values what we have here. A square plus B square is 100 plus 2AB is 80. So answer is 180. That's it. Alright, next one. A circular swimming pool is surrounded by a concrete wall 4 meter wide. Let's say OS. This is a swimming pool and this is surrounded by this concrete wall. So this will be how much? 4 meter. If the area of the concrete wall, that is, let's say this area of the concrete wall, let me call that as S1 or A1 area, or in simply AC, area of the concrete wall, fine. And this is the area of the swimming pool, SP, swimming pool, fine. If the area of the concrete wall surrounding the pool, that is AC, is equal to 11 by 25 times the pool, that is ASP. So this is what they've given. So with this we have to find out the radius of the pool, fine. So let me assume the radius of the pool as R. Okay, let's say this is S and this is R, fine. How do I express this? What is this area of the concrete wall? I can write the area of the concrete wall as pi into R plus 4 square minus pi R square. Hope you are following. This must be equal to 11 by 25 times the area of the pool, that is pi R square. So solve this. Pi anyways gets cancelled. I can just eliminate that. I have R plus 4 square is equal to R square, 11 by 25 R square plus R square. So that will be 11 plus 25, 36 by 25 R square. Further, R square plus 16 plus 8R is equal to 36 by 25 R square. So this is going to be 25 R square, and then you have 16 into 25, which is 400. 8 into 25 is going to be 25 into 8, 200. Yes, perfect. So 400 plus 200 is equal to 36 R square minus 25 R square, or 11 R square. So I have left R here. Yes, okay. So it's an equation now, a quadratic equation. So which is 11 R square minus 400 plus 200 R, or minus 200 minus 400, okay, is equal to 0. Well, so this, what I will do is I will do this as 220 plus 20. Okay, when you factorize it further, you will get R is equal to either 20 or R is equal to minus 20 by 11, right? So this cannot be negative. The answer is R is equal to 20. Hope this is clear. Don't make the mistakes when you are solving this quadratic equation. The whole problem, you have actually got the solution the moment you arrive at this particular equation, that is pi into R plus 4 square minus pi R square is equal to 11 by 25 times pi R square. So the moment you understand this, or you get this equation, the next part, please take care of your calculation. That's all. Great. Next question. The perimeter of a semicircular area is 18 centimeter. So what is the perimeter of a semicircular area? It is this as well as this, right? So if this is R, then the perimeter will be nothing but pi R plus 2 times R. This is equal to 18 centimeter is what they are saying. So I'll take out R common. You have 22 by 7 plus 2 is equal to 18, or 7 to the 14 plus 22, that is 36, is equal to 18. You have R. So 18 2 times, or R is equal to 7 by 2, or 3.5 centimeter. Very simple direct question. Okay. A wire when bent in the form of a square encloses an area of 484 square centimeter. So if A is the side of the square, I will not draw it. This we can, we'll have to solve it with the equation. But one thing, whatever we have learnt earlier, I have given you one comparison that when the perimeter is same, then the area of the circle is the maximum. Okay, so it has to be, the area of the circle has to be more than 484. So I can just rule out option A, but remaining 3 I will have to validate. So let's solve it. What they have said is, if A is the side of a square, then A square is equal to 484. Then what will be A? 22. 22 square is 484. Then what is 4A? Which is nothing but the perimeter of the square, which is equal to 88. Now this is equal to 2 pi R, perimeter of the circle. Correct? So 88, you can say it's divisible by 22, and you have 22 by 7. So 2 into 22 by 7 into R. So this and this cancels, you get 44 and 88, 2. So R is equal to 14. Hope this is clear. Great. So the moment you get R is equal to 14, the next thing that you are supposed to find is pi R square. Pi R square is 22 by 7 into 14 into 14. 7 2 times. You have 44 into 14. 44 into 14 is 440 plus 44 into 4, that is 160 plus 16, 176, which is nothing but 6. 7 plus 4 is 11, and 616. Answer is option C. The multiplication you can do it directly, no problems. I'm just comfortable with my method, this method, that's all. Anyways, I hope this is clear. Let's move on to the next one. Next one, 3 circles of radii 3.5 centimeter, 4.5 and 5.5. Okay, they touch externally. Great. The perimeter of the triangle formed by joining the centers of the circle. So let me join the centers. Fine. So this is R1, this is R2, and this is R3. Fine. So if you see the perimeters is nothing but, the perimeter of the triangle is nothing but 2 times the sum of the radius. Hope this is clear. Okay. So sum of the radius is 3.5, 4.5, 5.5. When you add them, 4.5 into 3, basically it's average. So you get 13.5. So into 2, you get 27. That's all. Answer is option A. Next. Read the question. ABCD is a parallelogram in which diagonals AC and BD intersect at O. EFGH are the midpoints of AO, DO, EFGH. Okay, doesn't matter. And then the ratio of the perimeter of this quadrilateral, small quadrilateral, joining the midpoints to that of the bigger one. All right, now observe, we have done already something like this. If this is the midpoint, okay, and consider this triangle, that is ODC. If F and G are the midpoints, and if this is the line joining the midpoints, then this FG will be half of that of DC. So that's the logic that will be applying for this question. So for example, let's say if this is 2, then this is 2, and let's say if this is 4 and 4, I mean, I'm just assuming, then this will be 1, this is 1, and this is 2, this is 2. So add the values, that is 2 plus 1, 3 into 2, overall 6. 6 is the perimeter of the smaller quadrilateral, and that of the bigger one is 4 plus 2 plus 4 plus 2, that is 4 plus 2 is 6, into 2 is 12. So the bigger one is 12. So you can clearly see the ratio is 1:2. So it is initially they have given EFGH, so the ratio is 1:2, not 2:1. So there is no option 2:1. So you are safe with respect to that, option C. Easy? This is a very easy question actually. 25th, straightforward question. 4 sides of quadrilateral are in the ratio 2:3:4:5. Perimeter is given as 280. Length of the longest side. So let me add the parts. 5 plus 4 9 plus 3 12 plus 2 14. So 5 by 14. 5 why 5? Because they are clearly asked longest side, right? So 5 by 14 of 280, which is 14 20 times, and 20 into 5 is 100. So the length of the longest side is 100 meters. Okay. Read the question. ABCD is a parallelogram in which diagonals AC and BD intersect at O. EFGH are the midpoints of AO, DO, EFGH. Okay, doesn't matter. And then the ratio of the perimeter of this quadrilateral, small quadrilateral, joining the midpoints to that of the bigger one. All right, now observe, we have done already something like this. If this is the midpoint, okay, and consider this triangle, that is ODC. If F and G are the midpoints, and if this is the line joining the midpoints, then this FG will be half of that of DC. So that's the logic that will be applying for this question. So for example, let's say if this is 2, then this is 2, and let's say if this is 4 and 4, I mean, I'm just assuming, then this will be 1, this is 1, and this is 2, this is 2. So add the values, that is 2 plus 1 3 into 2, overall 6. 6 is the perimeter of the smaller quadrilateral, and that of the bigger one is 4 plus 2 plus 4 plus 2, that is 4 plus 2 is 6, into 2 is 12. So the bigger one is 12. So you can clearly see the ratio is 1:2. So it is initially they have given EFGH, so the ratio is 1:2, not 2:1. So there is no option 2:1. So you are safe with respect to that, option C. Easy? This is a very easy question actually. Well, 27th is about the cylinder. You can just see this is a cylinder wherein, you know, this is the base, and then height is AB, okay, or this dotted lines, what you are saying, that is the height of a cylinder. Now what is that they are saying is the heights of two cylinders is in the ratio 1:2. Fine. The ratio of their radii when the volumes are same. So volume formula, what is the volume of any cylinder? It is nothing but the area of the base, okay, the area of the base multiplied by the height. Now how do you define the area of the base? Let's say that the radius is r, the radius of the base is r, then the area of the base becomes pi r square multiplied by the height. This gives you the volume of a cylinder. All right, now let me take the first one as pi r1 square and h1, that is the volume 1, which is equal to the second cylinder that we are talking about is r2 square and h2. Now the ratio of heights is given as 1:2, right? So pi r1 square will be equal to pi r2 square into 2. You can also cancel pi. The ratio of the radii will be r1 by r2 is equal to 2 by 1, or square root of 2 by 1. Great, because this has square, When it shifts, it becomes square root. Answer is option A. Well, move on to the next one. The base radii of two cylinders are in the ratio 2:3 and their heights are in the ratio 5:3. The ratio of their volumes. Volume of a cylinder is given by pi r square into h. So let me call it as pi r1 square into h1, and then pi r2 square into h2. So we have to find the ratio of this. Radius is in the ratio of 2:3. Okay, so anyways I'll cancel pi. So that gives me radius, that gives me 2 square and 3 square, and then h1 is height, so into 5 is 2 into 3. As simple as that. So this is going to be 2 square is 4, 4 5s are 20 is 2, 3 square or 3 cube is 27. That's it. Option B is the correct answer. Next one. Okay, so we have a question on hollow cylindrical tube. 20 centimeter length, I mean the overall height is 20 centimeter. 1 second. Yes, this entire length, I mean the height is given as clearly 20 centimeter, and then it's a hollow cylinder, all right. So what they've given is the external diameter. The external diameter is given as 8 centimeters and the internal is given as what? 6 centimeters. So diameter, right? Yes, diameter. This is 8 centimeter and internal, 1 second. Yes, this is given as 6 centimeters. That gives me the first radius, that is the external radius. I'll call it as RE. RE as how much? 4 centimeter, and Ri is equal to 3 centimeters. I'll tell you why this is important. What is that we are looking for? The volume of iron used in making the tube. So volume of iron used in making the tube is this layer that you are seeing in red. How can I get that? I can get that by removing this the volume of the smaller cylinder from the volume of the bigger cylinder. The bigger cylinder is the one with the base diameter 8 centimeter, and the smaller cylinder is the one with the base diameter of 6 centimeter. Hope this is clear. And we know the formula for volume of the cylinder, which is nothing but area of the base, that is pi r square, into height. So volume of the bigger cylinder is going to be pi into r square is, okay, I'll keep it as, I'll keep it as pi h into re square minus ri square. Hope this is clear, because pi h is common in both bigger cylinder and the smaller cylinder. Hope this is clear. So what is re square? Re square is 4 square minus 3 square, right? H into 22 by 7 will be equal to, so 4 square is 16 and 3 square is 9. This value will be 7 and gets cancelled. So you have overall 22h, or 22 into height is 20 centimeters. So your unit will be in terms of cubic centimeters. That's something you need to take care of if in case the units are in different overall measurements, but here everything is in terms of centimeter, nothing to worry. So 22 into 2 is 44. So your answer is 440 cubic centimeters. Yes, hope this is very clear, whatever you are seeing right on the screen now. So whenever you have questions on hollow cylinders, and if it's about the thickness of the pipe or the cylinder, then you can always go with this direct formula, that is re square minus ri square, where re is the external radius and ri is the internal radius of the hollow cylinder. Fantastic. Let's move on to the next question now. Question number 30th. Read the question. The radii of the base of two cylinders A and B, let's say it's the bigger one, cylinder A, and the smaller one is cylinder B. The ratio is 3:2. Okay, that DC divided by BC is 3:2, or BE is 3:2. All right, great. 1 second. Okay, now I think it is more visible. Yeah. And the ratio of the height is n:1. For example, if the larger cylinder, if the height of the larger cylinder AC is n, then BA will be equal to 1. If the volume of cylinder A is 3 times that of the cylinder B, the value of n is. Great. So this is just for you to make the visualization process a little easier, that's all. Now let's get into the solution part. They have clearly given the volume of cylinder A is 3 times the volume of cylinder B. So what is the formula for the volume of cylinder? It is nothing but pi r square into h. And how is this? Very simple. Pi r square gives you the overall area of a base of any cylinder, and when you multiply that by the corresponding height of it, you get the overall volume. Fine. So in this case, for the first cylinder, that is A, this will be pi into r square. I'll take it as 3x square, but I will not take x since we are talking about the ratio, and x on the other side gets cancelled when you are writing it for B as well. Alright, so I will directly take it as 3 square, and then height is nothing but n. So now this is equal to 3 times the volume of cylinder A is equal to 3 times that of B. So this will be pi multiplied by 2 square and 1. Hope this is clear. Solving this, what you will get, 9n is equal to 12, or n will be equal to 4 by 3. Very simple question. Great. We'll go to the next one. Question number 31. Read the question. A hollow iron pipe is 21 centimeter long. Its exterior diameter is 8 centimeters. Okay, so what they are saying is the length is 21 centimeter and exterior diameter refers to from this point to that point, right? Okay, this is 8 centimeters, and then they have given the thickness is how much? 1 centimeter. So great. Now if the thickness of the pipe is 1 centimeter and iron weighs 8 gram per centimeter cube, so it's a centimeter cube, then the weight of the pipe is, this correction, all these small corrections that will be made correctly and then uploaded, don't worry about that. So now what we are supposed to find is the volume of this pipe, okay, with this thickness, that is 1 centimeter cube. How can we find that? Very simple. Treat this hollow space as one cylinder, and you already have another cylinder with the radius of, consider 4 centimeters, because external diameter is 8 centimeter, so this is going to be 4 centimeters, right? Hope this is clear. Similarly, the internal radius, okay, this is going to be how much? 1 centimeter less than 4, so it is going to be 3. So hope this is clear. So we will remove this hollow space volume from the volume of the cylinder considering external radius. Hope this is clear. That will give us the volume of the pipe. Then you multiply it with the density of the material or iron, you will get the value of the weight. Great. And we have done something similar already. Question number 29 is exactly similar to this, but they've asked something else. Anyways, now what will be the volume of the pipe? It is nothing but pi into h multiplied by minus internal radius. Hope this is clear. We have already established this relationship in the previous 29th question. So this is nothing but 22 by 7 into what is the height, is given as 21 centimeter, and everything is in terms of centimeter, and this is also in terms of centimeter cube, so automatically we'll get the value in terms of grams, then we'll convert that to kg. Fine. So what is re square? External radius is this is re, so that is going to be 16, and what is internal radius? This is internal radius, ri, that is going to be ri square, right? So it's going to be 9. Solve this, you will get 7 3 times, and then 22 into 3 into 16 minus 9 is 7. Hope this is clear. Now this needs to be multiplied by what? The density to get the weight. So just write this as 7 into 22 into 3 multiplied by 8. So I'll go with 22 into 3, that is 66, and 7 and 8 is nothing but 56. So the Vedic math method. Okay, so 6 6 are 36, and then you have 69, and then you have 36. So your answer is 3696 in terms of grams. Okay, this has to be converted to kg, so it's going to be 3.696 kg. Option C. Okay, let's move on to the next one. 32nd, similar kind of question. Read the question. Volume of the metal of the cylindrical pipe is given. Volume is given. Length of pipe is given. So length of pipe is this, that is 14 centimeter. And then the external radius, let's say this is the external radius joining the center and the exterior end, that is 9 centimeters. Well, so for any of the problems with the hollow cylinder kind of problems, obviously when they're given it is a cylindrical pipe, it is self-understood it's a hollow pipe, right? I mean, when they say it's a pipe, it is self-understood it is hollow. So now we know the formula for the volume of a pipe, that is pi into h multiplied by Re square minus Ri square. Well, I think we have already solved 2 questions based on this particular formula. So this is equal to 748. 22 by 7 into the height is 14 into 9 square minus R1 square is equal to 748, or 7 2s are, and then you have 44. This is 748 by 44. So 44 1s are, and then you have 308. Unit digit 4 into 7 gives me 8. So into 7, 7 4s are 28, and then 30. Yes, it is 17. So this is n square minus R1 square. So n square, 9 square is how much? 81. 81 minus 17 gives me 64. So R1 square is 64, or R is equal to 8. Great. Now the internal radius I have got, which is equal to 8. What is the external radius? External radius we've already used, that is 9. Yes. Then what is the thickness? If internal radius is 8 and external radius is 9, the thickness has to be 1. 9 minus 8, 1 centimeter. That's your answer. Option A. Let's go to the next one. Okay, next one. The radii of the base of a cylinder, the base of a cylinder of the radii, and the cone, the ratio of this to this, okay, is root 3 is to root 2. Root 3 is to root 2. And then the ratio of the heights, okay, this and this, that ratio is given as how much? Root 2 is to root 3. So obviously you can clearly see the height of the cone is more and the radius of the cylinder is more. Anyways, now this is just for your reference. Their volumes are in the ratio of. Now volume of cylinder, we know the formula for volume of cylinder is what? The area of the base, that is pi r square, into the height of the cylinder, okay, that is of cylinder. And what about the cone? The cone is 1/3 the volume of the cylinder. Actually, that's the way in which you get this volume of the cylinder. Now that is nothing but pi r square into h divided by 3. The radius is different, so I'll name it as r1 h1. This is r2 h2. Fine. Since it is the same, two different things, and I'm comparing. That means even on the left hand side I have R1 and right hand side also I have R2, and even this is same, the order is same. So H1 also, instead of considering it as root 2x and root 3x, I will directly take it as root 2 and root 3 because on both the sides I have, and anyways if I take x it gets cancelled, right? So now pi into R1 square is 3, or 1 second, I will cancel pi also, yeah. So R1 square is 3 and H1 is root 2. Okay. So R2 square is 2, that is root 2 square, and H2 is this one, that is root 3 divided by 3. This is the overall ratio of the volumes. Now we'll have to adjust some values. So this will be nothing but root 2. This 2 you can write it as root 2 into root 2, and root 2 can cancel. And this is going to be 3 into 3 or root 3 into root 3, I'll write, divided by this root 3. So you can cancel that. So you will get the value 3 root 3 is to root 2. Great. Fantastic. Move on to the next one. If diagonal of a cube is root 12 centimeter, then its volume in cubic centimeter is. Great. See, diagonal of a cube is nothing but a root 3, which is equal to root 12. So if that is the case, a is equal to root 4, root 12 by root 3, which is 2. So what's the volume? Volume is a cube, which is 8 units. Very simple, straightforward question. Great. Let's move on to the next one. Next one. The edges of a cuboid are in the ratio 1:2:3. Its surface area is 88 centimeter square. The volume of the cuboid is. Fine. Now look at the options. I mean, I was just praising this particular website, right? So this is the reason. Well, I will keep the ratio as 1:2:3. So it will look something like this. Yes. Now they have given the surface area, which is equal to 88 centimeter square. Now since the ratio is this, what I will do is I will take this as, I'll consider this side as x, this as 2x, this one as 2x, and the other one, this length, as 3x. Great. Now what do you mean by this surface area? We'll have to add the surface area of all these layers, okay, all these the planes. Okay, for example, this is the top layer, the top plane that you're seeing. So similarly, you have a bottom, and then there are overall 4 sides. Now that has to be added. How do you find out that? Very simple. Overall, if you consider this face, okay, this is exactly equal to that. Fine. And the value of that is going to be 2 times x into 2x. This is x and this is 2x. So similarly, you have the top layer, if you see this, and the bottom, which are same. So I will multiply even that by 2 plus 3x into 2x. Okay. Plus, now you are left out with this side, that is 3x into x. 3x into x. Great. So this is something which you will have to visualize and immediately write. Now, should you actually do all this in the exam? Definitely not. If you observe the numbers, it is nothing but I've taken 2 out of 3 in each of the time. So for example, the first term is 1 into 2, that is 1 into 2, or x into 2x. Second time is 3 into 2, right? Third time is third and the first. But this is just for the conceptual clarity, that's all. This will be how much? Calculate this. You must get overall, okay, let's do that. 2x square plus 3 to the 6x square plus 3x square into 2 must be equal to 88. And 6 plus 3, 9 plus 2, 11, or 22x square is equal to 88, or x is equal to 2, because x square is 4, x is equal to 2. Great. You have got the value of x. Now I have got the actual value of the edges, that is 2, 4 and 6. That is 1:2:3, and the value of x is 2, multiplication factor is 2. So 1 into 2 is 2, 2 into 2 is 4, 3 into 2 is 6. Once you have the the edges, the formula for the volume of a cube is nothing but the product of these 3 edges, 2 into 4 into 6. 4 to the 8, 8 6 the 48 cubic centimeters. Centimeter cube. Option C. Hope this is clear. Brilliant. Let's move on to the next one. 36th. A cistern 6 meter long. Cistern means water tank. Okay. A 6 meter long and 4 meter wide contains water up to a depth of 1 meter 25 centimeters. So let's say that this is the water, right? And let's assume that this particular mark or this length I mean, we call it as depth, right? So depth is 1 meter 25 centimeters, which is nothing but 1.25 meters. Okay, so if this is the case, total area of a wet surface, now you can see that all the four walls, okay, a part of it, that is till 1.25 depth, that is wet, and then there is one more surface which is wet, that is the floor of the you can see it very clearly, I mean, common sense. So floor of the tank. I have two things to consider now. One is 1.25, which is depth, multiplied by 4, and then similarly this 1.25 into 6. The same thing happens on the other two sides. So 1.25 into 4 plus 1.25 into 6, 2 times, plus the floor. The floor is 6 into 4, that is 24. All the units are in terms of centimeter. No, you have the one in centimeter, other one is meter. You need to take care of that as well. Let me convert that. Oh, sorry, we have already done it, right? So 1 meter and 25 centimeter is nothing but 1.25 meters. So everything is taken care of, nothing to worry about it. So this value must give us the overall total area of wet surface. So calculate 6 and 4, 10. 10 into 1.25 is 12.5. 12.5 into 2 is 25. 25 plus 24 is 49. Answer is option D. So what did I do here? I have taken 1.25 common. I will be left out with 6 and 4. So 6 plus 4 is 10. So 1.25 into 6 plus 4, that is 10, will be, you will get 12.5. 12.5 into 2, this 2, you get 25. And you already have 24. You add them, you get 49. Great. Let's move on to the next one. 37th. Water flows through a cylindrical pipe. This is a cylindrical pipe whose radius is 7 centimeter at 5 meter per second. So what does that mean? 5 meter per second, the speed. It's nothing but, for example, if in case this is 5 meters, then it simply means that the volume of the water inside the cylinder of length 5 meters gets emptied in 1 second, or this much amount of water, okay, that can be filled in this particular cylinder falls into the tank every second. Okay, now the next thing is the time it takes to fill an empty water tank with height 1.56 meters. They've given the dimensions of the tank. Great. So the question is overall the time it takes. So what is the time it takes to completely fill the tank? It's nothing but the overall volume of the tank divided by the volume of this cylinder. Hope this is clear. The reason being, the volume of the cylinder is nothing but the amount of water that is being filled in the tank every second. So you will end up getting the value, the answer in terms of seconds. Let's start our calculation. The volume of the cylinder is given by pi r square into h, where the radius is clearly mentioned as 7 centimeter. Now that is something that you need to take care of, the units. So everything is in terms of meter, even the area of the base is given in terms of square meters. So I'll convert 7 centimeter to meters here itself. So 7 by 100 into 7 by 100, right? Great. Multiplied by the height. Height here you have considered it as 5 meters. Fine. Next thing is the volume of the tank. Volume of the tank is simply 1.54 meters into 3 into 5. So overall it is going to be 1.54 meters into 3 into 5 divided by this value. I'll just keep it like that, 22 by 7 into 7 into 7 into 5 divided by 10 power 4, or okay, 1.54 and 22. Remember this number 1.54. You must have observed this number many times in this mock test or any of the chapters in mensuration. This number keeps appearing. The reason being, it's a multiple of 22. 22 into 7 is 154. All right. So 22 how many times? 0.07 or 7 by 100. I'll write it as 7 by 100. Then you have 5 and 5 gets cancelled. You have 1 7 7, you can cancel it there. You are left out with 3 and 2 zeros gets cancelled. These zeros, that is nothing but 3 into 100, 300 seconds. 300 seconds, convert that in terms of minutes, you get 300 divided by 60, which is nothing but 5 minutes. Your answer is option B, 5 minutes. Question number 38. Find the length of the largest rod that can be placed in a room 16 meter long, 12 meter broad and 10 2 by 3 meter high. Fine. So now this is just a representation. It is not with respect to the scale. It's a cuboid basically. So in a cuboid, you will have two kinds of diagonals. One is a face diagonal. RU is a face diagonal. And then you have a space diagonal. For example, RS. Hope this is clear. The largest rod will be, the length of the largest rod will be equal to the face diagonal, okay, RS. And in a cuboid, overall you have three face diagonals. When you connect the opposite vertices of the cuboid, you will get the space diagonal. The length of all these three space diagonals will be same, and it is given by root of sum of the squares of the sides of the cuboid. 16 square plus 12 square plus, what is 10 2 by 3? It is 32 by 3. So 32 by 3 square. Solve this, you will get 16 square is 256, 12 square is 144. When you add them, you get 400 plus 32 square divided by 9 under root. So this will be, what is 32 square? 32 square is 1024. 1024 plus 3600 under root divided by 3. This will be 4624. All right, under root. So how do we find out the square root of these numbers? Now observe very carefully. Think about any number, the square of which is something near to 4624. What you get is 70. 70 square is 4900, which is more than the given value. So what is 65 square? Number ending with 5, you can easily find the square. It always ends with 25, and then you multiply this number, the number before 5, multiply this with 1 more than that. For example, 6 into 6 plus 1, 6 into 7 is nothing but 42. The value lies between these two. Great. Now think about the number which could be the possible answer. For example, 67 square does not end with 4. 68 square ends with 4. All right, 68 square ends with 4 because 8 square is 4. And I am assuming that this is a perfect square and directly taking 68 as the value. You can even cross verify this. You can find the square root in however different methods that you actually know. So I will not go for that. So 68 by 3, you will have 3 2s are 2 by 3. So 22 2 by 3 meters is the right answer. Great. Now another thing is finding the square roots. I'm sure you know the method. With the same method, you can find the square root of this number. That's one way. Or like this, if you do, and also later you can cross verify. 68 into 68, multiplication of that. Even, I mean, if you are quick with the multiplication, you can cross verify with that. I mean, I have cross verified already. So 68 square will be equal to 4624. Hope this is clear. Let's move on to the next one. The volume of a cuboid is twice the volume of a cube. One second. If the dimension, one second guys. Yeah. The volume of a cuboid is twice the volume of a cube. If the dimensions of the cuboid is given, the total surface area of the cube. Fantastic. Very simple question actually. So the volume is given as 9, 8 and 6 of cuboid. That is 9 into 8 into 6. Volume of cuboid is twice that of cube. So volume of cube is half of that of this. That is 9 into 8 into 6 divided by 2, which is 9 into 4 into 6, or 9 into 4 is 36. I will write the same thing as 6 into 6 into 6 cube. Why? To get the length or the edge of the cube, which is A is equal to 6 units. Hope this is clear. Once I have the length of the edge of the cube, then the volume is nothing but A cube, which is 6 cube or 216 cubic unit. Surface area. Oh, sorry, they have asked for surface area, right? My mistake. So I have found out the A is equal to 6. If A is equal to 6, then surface area is nothing but 6A square. Correct? The reason being, there are 6 faces and each face area is nothing but 6 square. So that this will be equal to 6 into 6 into 6. Oh, apparently even that is also same. That is nothing but 216 square units. Obviously the units will be different. Hope this is clear. Let's move on to the next one. The slant height of a conical mountain is 2.5 kilometers. This is 2.5 kilometers. The area of the base is given. The area of the base is 1.54 kilometers square. The height of the mountain, this is what we are supposed to find. Fine. With the area given, we can find the radius of the base, and with that and slant height, we can find the height. So now area is given as how much? 1.54, and this is equal to pi r square. So this is 22 by 7, and 154 is 22 into 7. We have already done this. Since it is 0.54, I'll just take it as 0.22 into 7, or I can also write this as divided by 100 r square. So r square will be equal to 49 by 100, or r is equal to how much? 7 by 10, or 0.7. Radius is 0.7 kilometer, right? So height of the mountain, now height of the mountain is nothing but, you can go with the Pythagoras theorem. This is 90 degree, so you have slant height, it is 2.5 kilometers, and this is 0.7 kilometer. So the height will be nothing but, height will be square root of 2.5 square minus 0.7 square. Either you can solve it, you will get the value as 2.4 square. And how is that? 7, 24 and 25, they are Pythagorean triplets. 7 square 49, 24 square is 576. When you add that, you will get 625, which is 25 square. So remember this, all these are very important, and it's going to save a lot of time of yours. So you have a decimal point, that's all, that's the only difference. So it is 2.5 square, or h is equal to 2.4 kilometer. Great. Next one. All right, question number 41. If S denotes the area of the curved surface of a right circular cone. So curved surface means we are talking only about this surface, not the base. Okay, we are not talking about the base here. This is the base, so leave that part. So whatever you can see, the remaining slant surface, that's the curved surface. Fine, great. Now one second. Yeah, now this curved surface is given by pi rl, where r is the radius and l is the slant height. I will take the height of the cone as h, and the semi-vertical angle, they have given the semi-vertical angle as alpha. This is the semi-vertical angle. Fine. And now we have to express this pi rl, which is equal to s, in terms of pi and h. That means I have to express r in terms of h, that is radius in terms of h, and l in terms of h. It is possible because we have alpha, and we can express h in r and l in terms of h and alpha, all right, with the use of trigonometric ratios. So clearly l is equal to h secant alpha, and r is equal to this is alpha opposite, and this is the base, so h tan alpha. Hope this is clear. So this gives us, I mean, just for your confirmation, what is secant alpha? In this case, it is L by h, right? L by h. So just observe, secant alpha is nothing but the hypotenuse divided by the base. Clear? Similarly, what is tan alpha? Tan alpha, in this case, it is nothing but r by h. So tan alpha is the opposite divided by the base. Clear? Similarly, what is secant alpha? Secant alpha in this case, it is nothing but the hypotenuse divided by the base. Similarly, what is tan alpha? Tan alpha in this case, it is nothing but r by h. So tan alpha is the opposite divided by the base. So it is r by h. Great. So you have expressed L and r in terms of h and alpha. So just substitute the value in the place of pi rl. So you will get pi into r is h tan alpha and L is h secant alpha. So I'll directly write h square secant alpha. So look at the options. You have this option here, that is option C, which is the same value. So that's your answer. The same problem can be also solved by assuming. You can assume alpha as 45 degree. Okay, if let's also do that. And it's interesting to solve problem in multiple ways. If you consider this as just 45 degree, and you can assume, since they have not given anything else. So if you assume this as 45 degree, then what happens is your radius will be equal to the height. Okay, h will be equal to r if this is 45 degree, and the hypotenuse will be equal to root 2r. Okay, instead of that, you can further simplify by assuming the height as 1, radius as 1, and this as root 2. Great. So your pi rl, that is s, will be equal to what? That's all, pi, because r and not pi into root 2, because L is root 2, right? Yes. So root 2 pi. Now if you look at the options, tan alpha is 1, you will not get this. So this is also 1, this is 1/3 of something, you will not get that. And then you have, because h is also 1, h is also 1, so there is no root 2 part. So that's why I'm eliminating those. Then you can see there are two options with secant alpha. So secant 45 is nothing but root 2, correct? And tan alpha becomes 1 in the case of 45 degree, and h is anyways is 1. So this is root 2 pi. Fine. But here you have 1/3. So that will not be the answer. Hope this is clear. You can solve in however way you are comfortable with. Fantastic. Let's move on to the next one. Next one. If h, c and v are respectively the height, curved surface and volume of a right circular cone, then the value of this equation. Now whenever you have a generic question like this, wherein there are no absolute values, you can always go with the assumption. It's going to save a lot of time. Before even we start assuming values, let's see what is that they have given. One is C, that is curved surface area. So C is equal to pi RL, okay, where this is the slant height L, this is the radius, and let's say this is the height. And then the volume is equal to 1/3 of pi r square h. Fine. What I will do is I'll assume r is equal to 1 and h also is equal to 1. So then this value will be equal to, okay, if h is 1 and r is 1, what is L? Root 2. So this will be root 2 pi, and this will be r is 1, h is 1, so pi by 3. Okay, let's substitute these values here. So 3 pi into volume is pi by 3 into h cube. H is 1. So c square is 2 pi square and h is 1 plus 9 into v square. 9 into v square is pi square by 9. Okay, cancels. 3 and 3 can cancel. You have pi square plus pi square minus 2 pi square, which is 0. Hope this is clear. Answer is option D. So if you without assuming, if you have to solve, definitely you can solve, but it will take more than 2 minutes. So just go with the assumption, you can save a lot of time. Fantastic. Let's move on to the next one now. Okay, you have your sphere here, right? You can, I mean, just for fun. All right. So the volume of a sphere is given as 88 by 21 into 14 cube. The curved surface of the sphere is the question. Fine. Now the volume formula is nothing but 4 by 3 pi r cube. Okay, which is equal to, they have mentioned 88 by 21 into 14 cube. See, the way in which they have expressed itself reveals that r is equal to 14. I'll show you how. So what is 88? It is 22 into 4. What is 21? 21 is 7 into 3. Correct? So what is this 22 by 7? Which is your pi. And you have 4 by 3, 4 by 3. Then the left out value is 14 cube. So r has to be equal to 14. Great. So now the curved surface area formula is nothing but 4 pi r square for sphere. So which will be equal to 4 into 22 by 7 into 14 into 14. So 7 2s are So this is 88, that is 22 into 4, and 14 2s are 28. You can go with your Vedic math. 88 is 64, then you have 64 plus 16, that is 80, 86, 8 or 16 plus 8, 24. So 2464 is your answer. 2464, option D. Brilliant. A hemisphere and a cone have equal base. Yes. If their heights are also equal, and the base diameter is also same, then the ratio of the curved surface area. So we are talking about curved surface area of a hemisphere and a cone. So what's the formula for this hemisphere? It is 2 pi r square, curved surface area, and for cone it is pi r l. We need the ratio between these two. All right. So this is the height of the cone, and this is the slant height, that is L, and this is the radius. So what I will do is I'll assume radius as 1, which goes for the sphere as well, radius as 1. And if radius is 1, even obviously the height will also be equal to 1 in the case of sphere. So if the height is also 1, if I assume that that of the cone, I have to, because they have clearly mentioned the height of sphere and the cone has to be same, right? So then length, the slant height, not the length, the slant height will be equal to root 2. We'll substitute here, pi and pi gets cancelled. You have r is equal to 1, so 2 is 2, r is 1, what is L? Root 2. So your answer is root 2 is to 1, option B. Hope this is clear. So if you don't assume, the only headache is you will have to convert this L in terms of R and H. Okay, so and then there will be no calculation. So let's avoid that by assuming. Definitely you can assume, since there are no any absolute values, you can go with R is equal to 1 and H is equal to 1. The problem boils down to very simple calculation. Next one. All right, question number 45. This is about a prism. We can see the prism clearly. It's a right angle triangle prism. Fine. So H is right angle, 90 degree. So there are 2 bases and then there are overall 3 lateral surfaces. Great. They have mentioned the sides of the base as 5, 12, and there will be one more, that will be 13. The reason is it's a right angled triangle. One second. Wait. All right. Okay. This is a right angle triangle, and if you consider this as 5 centimeter and this is 12 centimeter, the length of this side is going to be 13 centimeter. Why? 5, 12, 13 are Pythagorean triplets. Simple as that. And then they have given something else, that is the height of the prism is 10 centimeter. Total surface area. You can clearly see overall there are 5 surfaces that we have to consider, 2 base and then 3 lateral surfaces. And you can clearly see that all the 3 lateral surfaces, they share the same height, which is 10 centimeters. What will be the area of this side? This face? Nothing but this length into height. Similarly, what about this one? This length into height, and even here it is going to be this length into height. So can I directly say the overall surface area except the base as H into A plus B plus C, HA plus HB plus HC, where H is common, so I am taking out that. Hope you are following. Plus pi r, half into base into height, which is nothing but the area of the triangle, that is the base. You have 2 bases, right? So this will be equal to H is equal to 10 centimeters. So A plus B plus C is going to be 5 plus 12 plus 13 plus B into H, base into height. Now in the case of the base is, we have considered it as 5 and 12. We can interchange that, but not the hypotenuse, because in the formula we only have base and height, right? So this is going to be base into height, which is 5 into 12. That's it. Then you can just solve this to get the right answer. This will be 30 into 10, 300 plus 60, 360. and everything is in terms of centimeter, no need to worry about it. So it will be square centimeter. Answer is option A. Hope this is clear. Next, question number 46. The circumference of the base of a circular cylinder is given. Basically, if you consider this is circumference of the base that we're talking about, and then the height. So the height, all right, great. They're saying that the height is equal to the diameter. So this height is equal to the diameter of the base. So how many liters of water can it hold? Basically, how many liters means what's the volume? Volume for a cylinder is given by pi r square into the height of the cylinder. And they have mentioned the circumference. Circumference is 2 pi r, where r is the radius, okay, is equal to 6 pi. So what is r? R is equal to 3. And then they say the height is equal to diameter. That means height is equal to diameter means 2r. So the value of height will be equal to 6 units. Don't worry about the units. They have given in terms of centimeter, and then the options are also in terms of cubic centimeters. Great. So this is 6 and this is 3, and hence the volume will be equal to pi r square is 9 and h is 6, or 54 pi cubic centimeters. So that is option A. Hope this is clear. Fantastic. Let's move on to the next one. Okay, 47th. Marbles of diameter 1.4 centimeter are dropped into a cylindrical beaker and fully submerged. So let's consider this as a cylindrical beaker, and it is filled with water. Let's assume that it is filled with water. Then some stones are dropped, marbles. Now the assumption is the shape of the marbles is spherical. All right, let's say this is the layer till, the marbles has been filled, and then on the top there's some water. Then they have given that the diameter of the sphere, that is equal to 1.4 centimeters, and then the diameter of the beaker is 7 centimeters. So the radius is going to be 3.5 centimeters. We are always interested in the radius in the whole chapter. We have never used the formula, the diameter in any of the formulas. Great. Next, find how many marbles have been dropped in it if the water rises by 5.6 centimeters. So this distance is 5.6. Fantastic. Now what has to be equated? Observe carefully. Till here, if we consider this as the height, okay, the volume of the cylinder must be equal to the total volume of the stones. So that's what we'll be equating. So volume of the cylinder will be nothing but pi r square into h, which in this case is pi into r square is 3.5 into 3.5 into height. So height, I'll take it as 5.6. So this gives me the volume till this level, that is the water level, right? And then this must be equal to the number of, let's say there are some n number of marbles that we have dropped, multiplied by the volume of it. So volume of a sphere is nothing but 4 by 3 pi r cube. Pi r in this case is 3.1 second, r in this case is 0.7 centimeter, right? So it's going to be 0.7 cube. So we'll have to solve for n now. Observe, in this case pi and pi, they get cancelled, and then you have 0.7. So instead of writing it as cube, I will write multiply 0.7 into 0.7. So then 7 5 times, similarly 5 times, and then 7 8 times, right? And then you have n is equal to 3 by 4, or one more thing you can cancel, that is 4 2 times. Okay, so n will be equal to 3 into 5 into 5 into 2, that is 5 5 is 25 into 2 is 50, or 150. Great, the number of marbles is 150. Next one, a soap cake is of size 8 centimeter, 5 centimeter and 4 centimeter. The number of such soap cakes that can be packed in a box measuring this value. It's very simple question, direct question. So I'll just have to divide this by 8 into 5 into 4. Hope this is clear. So 8 7 times, and then 5 7 times, and then 4 7 times. So you get 7 cube, or answer is 343. Option D. Brilliant. Let's move on to the next one. Okay. 49th. It's about a cone. The height of the conical tank is given as 60 centimeter. So height is 60. And the radius, if diameter is 64, radius is naturally 32. The cost of painting it from outside. Fine. From outside means just observe this diagram. Well, this is the entire surface area, base and the lateral surface. Okay, if you open it. So now I'll just keep it open. The area of this is pi r square, and this one, the area of this surface is pi r l. You can also see, if you are really interested, then this particular overall perimeter, all right, and then you have this length which looks like radius. That is not the radius, it is the slant height. If you observe closely, it's, now see, whatever they are writing, that they are drawing now, this particular part, this is nothing but a slant height. So that becomes the radius for this part of a circle, and considering all those factors, you get the overall surface area as pi r l. The sum of these two, that's just for your knowledge and conceptual clarity, that's all. Now let's get back to the question. The sum of these two, that is pi r square plus pi r l, is what we are interested in. When we get the total surface area, we multiply this by the rate, then we get the overall cost. Okay, so what do we have? We have r, we have h, and we can find out L for sure. Look at the ratio now. R is 32, H is 60. The ratio of R is to H is going to be 32 and 60 divisible by 4. Yes, 4 or anything more than 4. Okay, let's do it with 4 first. 4, 8, and then 4. How many times? 15. Yeah, 8, 15. 8 and 15. If you observe, 8, 15 and another number forms the Pythagorean triplet. Which one is that? 17. Perfect. You can cross verify. 8 square is 64, 15 square is 225. When you add them, you get 289, which is 17 square. But the overall multiplication factor that we have used, 8 into 4 is 32, or 15 into 4 is 60. So L will be equal to 17 into 4, which will be equal to 34 into 2, that is, or 68. Hope this is clear. Instead of directly going for 60 square plus 32 square, you can always go by the ratio. Okay, so what does that mean? For example, if you take any Pythagorean triplet, let's say 3, 4, 5, then you multiply this by 2, you get 6, 8 and 10. Even this will also be Pythagorean triplets. That's the meaning of whatever I have discussed. So now I have L, I have R, so I can directly go with the substitution. Pi, I'll take out common, and then R, what is R? 32, so I'll take even that common. I'll be left out with R plus L. So R is 32, L is 68, sum of that will be equal to 100. Okay, this is the overall surface area multiplied by the cost. Cost is in terms of square meters. We'll have to convert that in terms of square centimeters. So always remember, I mean, nothing to remember, I'm sure you'll be knowing it. 1 meter is equal to how much? 100 centimeter, right? So 35 per square meters will be equal to 35 divided by 10,000, because you have square centimeters. And then you have, this is 22 by 7 into 32 into 35 divided by 100. Okay, so 7 5s are, and then 5 into 22, you get 5 2s are 10, and then 5 2s are 10, so 110. 110 into 32 is very simple. Whenever you have a multiplication with 11, you just have to write two numbers and in between add these two numbers. So it becomes 3520. 0 is from this 110, right? Well, so that's your solution. The answer is 3520 divided by 100. So it is 35.20. Option C. Hope this is clear. Let's move on to the next one now. All right. Question number 50. Ignore this part. All right. Now, the total number of spherical bullets, each of diameter 5 decimeter. 5 decimeter is nothing but 0.5 meters. That can be made by utilizing the maximum of rectangular block of lead with 11 meter length and then 10 and then 5. So overall volume of the rectangular block is how much? 11 into 10 into 5. Now using the same rectangular block, we'll have to come up with the spherical bullets. Correct? So let me assume the number of bullets as n, and then I'll divide this volume by the volume of one bullet. That will give me the total number of bullets. So volume of a bullet, which is in spherical shape, is 4 by 3 pi r cube. R is 0.5 by 2, 0.25. Instead of taking it as 0.25, I'll take it as 5 by 2, which is 2.5. 5 by 2 into 5 by 2. And then divided by 10 in each case, I will take it to the numerator. I'll make it as into 1000. Great. Now observe very clearly. Assume that pi is greater than 3. So I will assume instead of pi, I will take this as 3. So if I take this as 3, the overall denominator, will be lesser than the actual value. Reason being, pi should be more than 3. If the denominator is lesser, the overall value, that we calculate will be more than n. That is something that we need to take care of. So n will be less than this value, or this value will be overall more than n, or number of bullets. Hope this is clear. Fine. That's why there are options like less than 8800 and then greater than 9000. So let's see what is the answer that we get. Now with this whole equation, we can only end up getting the value of n less than. So immediately we can also mark this particular answer. But let's solve and see if we are right with our guess. 3 and 3 gets cancelled, and then 5 5 2s are, and then 2 2s are, 2 2s are, right. So then I have 2 2s are 4, 44 into 1000 divided by 2, divided by 5. This one, these 2 and 2 is 4. I have taken already. 4 into 11. That's all. Great. So this will be nothing but 5 200 times, and the answer is 44 into 2. That is 8800 is greater than n, or n is less than 8800, which is option B. Hope this is clear. Very beautiful question. They have brought in the concept of inequality. All right, not exactly inequality, just that a little bit of adjustment we're supposed to do and get the answer. Next one. If the radius of a right circular cylinder open at both the ends is decreased by 25%. Now this radius has been decreased by 25%, and the height has been increased. Fine. So now for this, what we'll do, the curved surface area thus formed is what we are supposed to find. In this particular cylinder, compared to this, what changes has happened? That's what we are supposed to identify. Great. Curved surface area in a cylinder is given by the perimeter, that is 2 pi r, into the height, correct? So that will give you the overall curved surface area, so into h. Now let's assume this is the curved surface area of the first cylinder. The second one, what has happened is the changes that has happened is r has decreased, reduced by 25%. So I'll write the new r as 3 by 4 r. Hope this is clear. 3 is less than 4 by 1, so 1 by 4th, that is nothing but 25%. Similarly, height has increased by 25%, so it becomes 5 by 4 h. So 5 is more than 4 by 1, so difference is, the change is 1 by 4th, which is again 25%. Hope this is clear. So it becomes 2 pi RH into 5 3s are 15 divided by 16. Now observe, 15 is less than 16 by how much? 1 by 16. So overall change, hope this is clear, 15 is less than 16 by 1, correct? So the change is actually 1 by 16th. So overall change with respect to the first one is 1/16th. 1/16th in terms of percentage will be, so that's why I was saying, remembering these fractions, 1 by 8, we know it is 12.5 percentage. And how did we get this? Simple, 1 by 4 is 25 percentage, correct? So if 1 by 8 is 12.5, clearly we can derive, get the value of 1 by 16, which is 6.25 percentage. So overall, there is a reduction of the curved surface area, and that is reduced by 6.25 percentage. Answer is option D. Hope this is clear. Next one. Okay. The amount of concrete required to build a concrete cylindrical pillar, okay, this is the pillar, whose base has a perimeter of 8.8 and the curved surface area is 17.6. Fine. What do we need? We need the overall volume. So volume of a cylinder is given by pi r square, that is the area of the base, into height. Fine. Now I need radius as well as height. So radius can be obtained from the perimeter, right? Perimeter is equal to 2 pi r, perimeter of the base, that is a circle. This, you can just see the overall when you actually open this, how it will be. Anyways, now P is equal to 2 pi r, right? So this will be equal to how much? 8.8, or pi r, or I can directly write r is equal to 4.4 into 7 by 22. Hope this is clear. So this is going to be 2.2 times 0.2 times, and this is 1.4. We have got the radius, which is 1.4, and then the height. Well, 1 second. Yes, great. Now the height, observe, the overall curved surface is nothing but this surface that you just saw. 1 second. This whole curved surface is nothing but perimeter. This length is equal to the perimeter of the circle. You can see that the same value gets, this whole thing is nothing but the perimeter multiplied by the height. So perimeter into height gives me the curved surface area, which is equal to, they have given 17.6, and perimeter is 8.8. So the value of h is 17.6. You can directly observe 8.8 into 2 times is 17.6. So height is 2 unit meters. Hope this is clear. Fantastic. I have got the value of r, I have got the value of h. Now I can directly substitute and get the value. So pi is 22 by 7, and then 1.4 into 1.4, or I will write this as 14 into 14 divided by 100 multiplied by height. Height is 2. Okay, so 7 2 times, then you have 22 into 14 2s are 28, 56. So 22 into 56, you can go with Vedic math. 6 2s are 12, and then diagonally you multiply. 6 2s are 12, and then 5 2s are 10, add them. So 12 plus 10, 22 plus 1, carry 23. 5 2s are 10 plus 1, 12. So it is 1232 divided by 100, correct? 1232 divided by 100, which will be equal to 12.32 meters square. Answer is option D. Great. Which of the following statements is not correct? For a given radius and height, the right circular cone has the lesser volume among the right circular cone and right circular cylinder. Obviously, it will be 1/3 of the right circular cylinder, right? So this is correct. And let's go to the next one then. Then that means that it's not the right answer, because the question is which of the following statements is not correct. Fine. Before you get into these, the values, the options with the numbers, let's understand the remaining options. Cutting a sphere into two parts does not change the total volume. Obviously, it does not change the total volume. So this is also correct. So that is not our answer. Option B, if side of a cube is increased by 10%, the volume will increase by 33.1%. Let's cross verify that. Let me take the initial side as 10. So 10 cube is overall 1000, right? So if I increase it by 10%, that means the side becomes 11, and 11 cube is 1331. So the difference between them is 331. So definitely the change is 33.1%. So this is also correct. That means we're left out with option C. That is our answer, which should not be correct. Okay, if you even cross verify, you will definitely get this will not be correct. Okay, you need not solve this. All right, so it's just that we'll have to rule out which are the correct ones and end up getting the wrong one. Hope this is clear. Let's move on to the next one. All right, 54th straightforward question. Volume of sphere is so much, radius is this. You must be able to do it yourself. 4 by 3 pi r cube. I will not solve this completely. 4 by 3 pi r cube is equal to 268.19. So r cube will be equal to 268.19 into 3 by 4 into 7 by 22. Please solve this yourself. I mean, be careful with the calculation. You will get r cube is equal to 64 or r is equal to 4. You will get 63.9 something, which you can assume as 64, and then r is equal to 4. That's it. Great. Next one. All right. The perimeter is given. That is the sum of these sides, which is nothing but 40 centimeters, and the area is given as 60 centimeters square. All right. Anyways, the length of the smallest side is, largest side is given as, let's say, 17 centimeter, and the smallest side we need, I mean, this is just a rough diagram. Don't go with that. Don't go with the, I mean, in terms of thinking that the triangle could be like this. No. Fine. So now what we will do is, with the perimeter and the area, we can actually find the value of the two sides when one side is given. Let's see how. Perimeter, knowing the perimeter, finding the area of the square, we have a formula that is nothing but square root of s into s minus a into s minus b into s minus c, where a, b, c are the sides. Correct? Hopefully, I mean, I'm sure this you will be knowing, where s is equal to nothing but perimeter by 2, semi-perimeter, which is nothing but 20 centimeters, and area, this value is 60. We'll substitute this. What is s? S is 20, and 20 minus a, I'll take 17 as a, so it's going to be how much? 3. And then you have 20, the other one of the sides, I will take it as b. Okay, but I will not keep c in terms of c only, but I'll express c in terms of b. And how can I do that? Because a plus b plus c is equal to how much? 40. A is 17. Okay, if I express c in terms of b, okay, plus b plus c is equal to 40. So c will be nothing but 40 minus 17 is 23 minus b. Hope this is clear. So s minus b into s minus 23 minus b, which will be equal to b minus 3, right? Because s is 20, and then you have minus of 23 minus b, so it will be b minus 3. Great. This will be equal to 60. Let me square on both the sides, or what else we can do? Okay, we have 20 into 3. I'll take this separately. This is root 60, and under the root I'll write s minus b into b minus 3. This is equal to root 60 into root 60. Cancel that. Then square it now. You get s minus b into b minus 3 is equal to how much? 60. Solving this, you will get the value of b as either 8 or 15. So smallest is 8. Okay, the other one, which will be 15. That is nothing but, if you take 8, you get the value of c as 23 minus 8, 15. So if you take the value of b as 15, you end up getting c as 8. The smallest anyhow is going to be 8 itself. So the answer is option C. Hope this is clear. A little bit of calculations. So be very specific with respect to the accuracy of the calculations. Apart from this, there is nothing in this question, just about the calculations. Okay, great. Question number 56. It's about the rhombus. Rhombus, I'm sure all of you will be knowing that all the sides will be of equal length, right? And the diagonals, they intersect by making a right angle. Okay, this is 90 degree. If length of each side of rhombus is 8 centimeter, the length of the longer diagonal when one of the four angles is 60 degrees. I'll assume this as 60 degree. If I assume this as 60 degree, then we know that the diagonal, they bisect. Okay, so this will be 30 degree. If this is 30, that is this particular angle. Okay, then this length EC, that is half of one of the diagonals, will be nothing but 8 cos 30, and similarly this one will be 8 sin 30. So which is bigger, 8 cos 30 or 8 sin 30? Sin 30 is 1 by 2, cos 30 is root 3 by 2. Definitely 8 cos 30 is bigger. So if that is the case, we want 2 times 8 cos 30, that is this and this, that is the length of the longest diagonal or longer diagonal in the rhombus. So it's going to be 2 into 8 into cos 30. 2 into 8 into cos 30 is root 3 by 2. Cancels. Answer is 8 root 3. Very simple question. Let's move on to the next one. 57th. An exterior angle of a regular polygon is 72 degree. Sum of all the interior angles is. Fine. It's a formula based question. So when you know the exterior angle, you can find the number of polygons in a regular polygon. All right. Then finding the sum of all the interior angles is also, again, it's formula based. Fine. So the number of sides will be equal to 360 divided by the exterior angle, it is 72. You get 5. And the number of overall, the sum of all the interior angles is nothing but 2n minus 4 multiplied by 90 degree or 90. Fine. So this is nothing but the sum of all the interior angles. Again, it's a formula based question, like I said. So 5 2s are 10 minus 4 is 6. 6 into 90, you will get 540 degrees. This is the sum of all the interior angles. Hope this is clear. Next one. All right. Read the question. I'll just make some adjustments. Okay. All right. Fine. Yeah, let's assume that this is the water tank, and cylindrical tank of diameter 35 centimeter is full of water. Okay, the blue color water we are seeing, just assume that to be water. If 11 liters of water is drawn off, you are removing some water, and because of which the level of water in the tank is reducing. What we are supposed to find is by how much it has reduced. Now, if you remove the water, they have given the volume of that is 11 liters. So that will be in what shape when it is in the cylinder? It will be in the shape of the cylinder itself. So we can just find out the volume of this particular space, that will be equal to 11 liters. Hope this is clear, right? So the formula for, again, the volume of a cylinder, I mean only this particular part, is, I'll take this as h before that. Yes, the volume of the cylinder is pi r square into h. Hope this is clear. And what is r? R is equal to 35 by 2. Now 11 liters is nothing but 11,000 centimeter cube. Okay, 11,000 centimeter cube, or you can also express it in terms of meters, but I want to keep everything in terms of centimeter because the options are also in terms of centimeter, right? You can look at all the options, all of them are in terms of centimeter. Fine then. So this is equal to 11,000, 22 by 7, radius is 35 by 2 into 35 by 2 into h. This is this h. Okay, we can easily get the value of h by properly doing the calculation. So be careful with the calculation, that's all. It's 5, and then you have 11 and 22. So I'll write this as 11 into 1000 So 11 two times, it's cancelled. You are left out with what? H is equal to 1000 divided by or into 2 divided by 5 into 35. Okay. All right. So 5 and then you have how much? 200 and once again 7 and then 5 how many times? 40. So 40 into 2, 80 by 7. 80 by 7 is 7. 11 times is 77, 3 by 7. So 11 3 by 7 centimeter, which is option D. Great, fantastic. Let's move on to the next one. Okay, now ignore this part. We don't need a diagram for this question. The overall volume of water that is flowing in the river is expressed something like this: 3 meter deep, 40 meter wide, and 2 kilometer in terms of length. And that's the overall volume of water that is flowing per hour. How much water will fall into the sea in a minute? Basically, fine, anyways, we'll solve this. It is nothing but 3 into 40 into into 40 into 2 kilometer is 2000 meters divided by, not in 60 minutes, that is not in 1 hour. What we want is per minute. So I'll divide this by 60. Whatever answer we get, the volume will be in terms of meter cube, and we have to express that in terms of liters. Remember this: 1 meter cube is equal to 1000 liters. Okay, very simple to even visualize. A big box, you can visualize a cube of 1 meter length. All right, something probably as big as this old TV boxes, right? And then in that you can hold probably 1000 1 liter milk packets. Fine, you can just remember this. So 1 meter cube is 1000 liters, right? Well, so this value is going to be equal to 4 into 3 is 12, 12 and then 6. So you get 4 into 3. This whole thing will be nothing but 2. Then you have 4000. Yes, 0 and 0 gets cancelled. 4000 meter cube, or 4000 multiplied by 1000. 3 more zeros, liters. Overall 1 2 3 4 5 6 zeros. 6 zeros you see in option B. Hope this is clear. Next one. Okay, last question. Read the question, understand it. So what they are saying is the height, let's say if this height is 1 unit, then the larger one, this will be 2 units. Hope this is clear. This is 2 units, right? Well, now observe very carefully. You can see 2 triangles, though, I mean, in the sense from this direction, though they are cones, but if you look at from this direction, it looks like a triangle, right? So wherein they are similar because the angle is same, and then even this angle is same for both. This is also same, so these two becomes the same similar triangles, and definitely the sides are proportional. So if this is the radius of the smaller cone, let's say let me assume that the unit is 1, okay, 1 unit, and then this radius will be equal to 2. The reason being the sides are proportional, and the height, I mean, if you look at this particular side of the smaller triangle, if that is given as 1 unit, and that of the other one, the bigger triangle, this height is 2 units. So going with the similarity and proportionality of the sides, you can clearly see that the relationship between the ratio is 1:2. That's it. So once you get that, you have actually solved the problem, because the volume ratio of smaller to that of the larger is nothing but r square into h is to r square into h. So 4/3 pi is same in both the case, because the volume is nothing but 4/3 pi r square, right? 4/3 pi r square into h. Yes, so 4/3 pi is anyways common, right? So now observe, in the smaller triangle, smaller cone, the radius is 1, and that of the height is also 1. What about the larger cone? It is 2 square into 2. So the ratio is 1:8. Answer is option A. That's it. Hope this is clear, guys. We have put some extra efforts to make this whole project really amazing. I'm sure that we get good response from you guys. If in case you need more supports, more help, then we are here. You can just send us any information, be it to our email address, or you can just put a comment below this video. We will get back to you. Hope to see you in the next video. All right, take care.